Hi, and welcome back to Digital Color Theory on FX PhD for the 11th week. I'm Lauren Meese. Hope you had a great week. In this week's class, I'm going to touch on logarithmic versus linear color space, film basics, printer points, and we'll do some dirt fixing. In last week's class, I talked about color correction for show openings, color correction for digital compositing, and digital compositing multi-layered color correction. Hope you enjoyed that. It was a lot of fun. For those of you that will be doing visual effects for the film and television industry, we'll take a look at the differences between film and video. The CCD is a charge-coupled device. It's an image sensor consisting of an integrated circuit containing light-sensitive capacitors. The CCD was invented in 1969 by AT&T Bell Labs. The lab was working on a picture phone. The essence of the design was the ability to transfer a charge along the surface of the semiconductor. The CCD receives a charge via photoelectric effect, and electronic images could be created. Photons, or light rays, hit the pixel array of the CCD chip and are converted into electrons. These electrons are then collected, rather like water drops would be collected in a row of buckets during a rain shower. When the bucket is full, it turns white, just like a glass of milk. The television system was designed in the 1940s by radio engineers. Radio engineers were familiar with recording audio, and they wanted to capture exactly what the performance was without any enhancement. The thing they weren't counting on was displaying those images on a contrasty CRT. The color space used initially was linear and didn't have good detail in the darker areas of the video signal. The human eye responds to light and color information differently over the full spectrum. As an example, it's easier to differentiate details in the lighter areas of an image. Harder to differentiate color information in the darker areas of the picture. This is due to the makeup of human eyes' rods and cones. The initial image from the cameras were unflattering, so a decision was made to alter the gamma curve of the video signal. Every frame of film has a thin, light-sensitive emulsion layer composed of randomly distributed microscopic silver halide crystals that are suspended in a three-dimensional pattern in gelatin. When photons of light strike the emulsion, a photoelectrical reaction takes place on the microscopic solid-state sensor. These sensors react logarithmically to light and form a latent image consisting of silver atoms embedded within the crystal structure. So what does that mean? Light hits a camera negative. It reacts with the silver halide crystals and turns them black. That stains the dye layers. The silver is removed, leaving those stained shadows on the film, and that's developed into the final image that we use. This is an oversimplification, but that's roughly what's happening. Now, when a laboratory processes the negative, the latent image is chemically amplified. This amplification chemically produces the dye image that formed the picture in a color negative film. Since the eye reacts logarithmically to light, the resulting dye image is very close to what we see through the viewfinder. The gamma of the negative film is around 0.6, and the gamma of a release print is between 1.6 and 1.8. That's why a negative contains so much more information than a release print. I think you'd be shocked if you saw an actual release print in a theater containing all the information of the original camera negative. Now, for transferring film to video, there's approximately 4 times the information on film than we can use in the broadcast video system. Some film stocks can be made of up to 15 layers. Image information is captured on a number of layers, so film does have 3D properties. Film has a depth of about 1/1000th of an inch. Now, another difference between film and video is the dynamic range between the two formats. In other words, the capacity for recording shades of tonality and colors from the darkest shadow to the brightest highlight. Film's dynamic range is around 1,000 to 1, and digital video cameras have improved greatly but are still around 100 to 1. Now, the HD 24p camera records well in the shadow areas when used at its rated speed, but it lacks the nuances you get with the film look. Digital video will blow out or clip highlights in high contrast scenes. The two formats can complement each other by using the strengths of each. So if you need to shoot outdoors, in unpredictable type weather, hot skies, bright traffic, vehicles driving by with chrome, shoot on film. If you're in a studio on a controlled stage, you can control the lighting, you can shoot video. If you're shooting outdoors at night, you may want to shoot video because it's quieter and you have a gain adjustment in the camera, so you get more image detail with less noise than you would with higher ASA film. For post-production, the two formats do coexist through a system that maps grayscale points with a lookup table. This is done so film can be displayed on television and vice versa. Now, a lookup table is a color space converter, gamma modifier, or a set of numbers applied to each pixel to change its gamma curve. This makes the image look correct on a video projector or video monitor. This only affects the output while the original is unchanged. And for a color monitor, there are 3 lookup tables, one for each channel. And here you can see with film as the blue line, there's a decrease of contrast on film versus video, which is a little bit more linear. Now, when you scan the film, at that point you need to define what color space is your final destination. If you're going to go log, then you're going to be doing data or film finish. If you go linear, then your YUV color space for television, and you have to pass that information along or be aware of your workflow. So when we do film dailies for editing, they're usually a compressed grade. So that's we take all the film color information, brightness information, and just kind of squeeze that down in a compressed grade in a linear format. And this allows the contrast to fit into a linear pipeline. And then after you do your video post, if it's a film finish, you'll go on to do a DI from there, but the original telecine scans are done as a compressed grade. Here's one image that was scanned in log space. It contains all the original grayscale information of the original scene. It looks quite flat to our eyes. Now, in order to see the Cineon or DPX file correctly, you apply a lookup table or LUT table to remap the file to be displayed within the capabilities of a monitor, and that's what you see on the right. So if you have a look at this clip, this is how film and video coexist that I've got. This show that I was working on shot this explosion with 3 cameras, and they used 2 HD, which are the top and the right-hand side, and then they shot a slow-mo on film, and you can certainly see that for a normal nighttime image you get like a nice looking noise-free image with the HD, but you can see once the highlights get up over 100, the pixels are full and they just turn white, whereas the film has total detail in it. You can see all the licks of flame right up into the hottest parts of the flame. So both formats do complement each other. Now, there was a question a few weeks ago asking if we could discuss what are printer points and how they work. So here we go. Up until the wide acceptance of digital intermediate workflows, the only way to affect the color balance change to a film once it's been captured on film is by printing using a contact printer and changing the light valves by means of a punch tape. The color timer would look at a frame from a scene and select the different filters needed in the red, blue, and green channels to give the DOP the look. Because film has been around for so many years, it's quite comfortable for the director of photography to want to continue to speak in these terms. Now, in a motion picture printer, you have a light source and light shutters that control the amount of light being allowed through the opening. The shutters are controlled by a punch tape that runs with a footage count of the film. When the film runs to a certain frame count, for example the 1,000-foot mark, the shutters alter the light output from the red, blue, and green to create the correct intensity and color balance for the scene. The scale of the opening is divided into a scale of 50 points. If you have a film that's exposed with the manufacturer's specs, the printer point should be 25, 25, 25 in red, blue, and green for a standard balance. The eye can see a change of less than a half a printer point. Digital intermediate color correction tools will allow you to mimic the controls of a traditional film printer to allow you to speak the same language as the director of photography. With the advent of video, you now have controls for gain, gamma, and black, and all the video tools that I've been speaking about for the past 11 weeks. Adjusting these values is similar to adjusting the brightness of the image. Here you have a nicely balanced image, so it happens that the lights are 25, 25, 25. Using a lower number makes the image brighter, and using a higher number makes the image darker. The numbers will have different values on each scene you're working on, as it's dependent on the density of the film. If you have a scene with mostly light information, the number will have more of a reaction. So here's just a note that each film printer is different, and the printer numbers you get on one printer won't work on another. I mentioned in a previous class that you as artists may have to wear the hat of director of photography, respectfully taking the images given to you and taking them to the next level. This includes adjusting the exposure and the color balance. DOPs have their own vocabulary, and it would be to your advantage to get a copy of, say, the American Cinematography Manual and take a look at it. It'll give you an insight into what equipment crews are using and what type of vocabulary they're using. It's the same for you and your vocabulary when you speak with the operators in the videotape room. You use certain phrases to get the job done, and so do they. In order for the color balance of a scene to be changed, if you're working with a DOP in a session, they might mention that they need to add a certain filter to the lens to get the correct color balance. DOPs may not be familiar with the lift, gamma, and gain controls, so they may ask for a filter by name. Here's two that are common. The 85B filter converts 5500 degrees Kelvin to 3200 degrees tungsten light. And there's the example there, from daylight to tungsten. These filters can either be used on the lens or over the lights. Here's the other one, an 80A filter. This converts tungsten 3200 degrees Kelvin to 5500 degrees Kelvin, daylight. I guess that part of what makes you a good artist is your ability to communicate to other people in your team in a familiar and comfortable manner. And understanding cinematography terms will go a long way in you fitting into the team pipeline. The other filter you'll hear about is an FLB, that's fluorescent light bulb filter. And this removes the harsh green cast caused by fluorescent lights. So there's your filter in reverse. Okay, I'm working on a film and doing all the color correction, and whoa, as I'm sitting here watching this stuff going through frame by frame, I happen to notice a piece of film that's broken off and it's fallen back on the image. As a colorist or a compositor, what I usually like to do is just make a note of this, and somebody's going to have to come and fix this, because this isn't going to pass quality control. When you send your show or your VisFX off to a broadcaster, they have technicians there that are going to go through and hand wind this tape through, and they're paid to find all the faults in it. And this is a piece of missing information that's pretty large, so I'm sure it's going to get kicked back. So I have two plans of action. First off, I'm going to let the producer know, the associate producer know that, hey, there's a large chunk of dirt on the film which needs to be fixed, and definitely mark the number down so somebody can come back and have a look at it. But I've already talked with the associate producer, and our game plan is, if it doesn't take you too long, go ahead and fix it. And I feel much better that I can hand this project off. You know, this is a film-based project, so any of the dirt, the film dirt that I see, as long as it doesn't take me too long, I'm going to fix. So I'll show you how to do that. First off, I'm going to isolate this frame. So I'm going to mark the in and the out of the frame, and I'm going to go back one frame before, and I'm going to see if there's any dirt on that, and that looks clean. Now my plan of attack is, I don't want to freeze these frames because, like I said, the technicians at the network, if they're hand cranking these things frame by frame, which they do, they're going to see there's a frozen frame. That'll get noted and get kicked back as an editing problem, that for whatever reason your playback deck stuttered and didn't play out a frame. Anyways, there's going to be a frame missing, and there'll be a note for that. So what I'm going to do is I'm going to isolate this mark that's on the film. So what I'll do is I'll copy this up. I'll make a copy of this frame, and I'm going to slide that in underneath. So I've moved the affected frame is right here, and I've made a copy of the clean frame one frame before, and I've slid that in underneath. Next thing I'm going to do is go into my favorites folder. I'm going to grab a mask shape and a mask feather. So I'm going to cut a hole. So I'll go up to the next track. There's my mask shape, and let me just pull this down so you can see what I'm going to do. I'm going to click on the centering option, and I'm going to put the center of this rectangle over on that spot, that speck, and that's going to cut a hole. Now I'm going to adjust the horizontal and vertical scale because I just want to cover it, and I'll make that 1010. So there, that frame, that portion of the frame is isolated, and I'm going to soften it because there's a time difference and a motion difference between the frame before and the one that I'm working on. So I'm going to kind of fuzz that up a little bit, so hopefully the motion will be hidden and all of that. So I'll do a soft edge on that, and then I'm going to reach up and hit the invert key, and if you watch the screen here, we should see that get zapped. And there's the hole that I've cut with a soft edge, and it's big enough. Now when I back this up and play it through, now having said that, I've seen a couple other specs there. There's another one that should be fixed, and there's probably more, but anyways, that's the biggest one. I let this roll through, and you can't see that anymore. So I feel comfortable now that I've been able, on my shot, I've been able to clean that up, and I can hand that off and say, that's as good as I can make it. Okay, so we'll go up to the next shot, and we'll have a look at this, and whoop. It's funny when you talk to people who aren't in this industry, and you ask them, did you see that white chunk of dirt, or that black camera dirt or whatever, and they'll always say no, and then you start to point it out, and you end up ruining their television or film viewing, pointing out these little imperfections. But anyways, so here's another shot. So again, what I'll do is I'll mark the affected frame. I'll go back and have a look at the frame before. Now we've got motion in here, so we have to deal with this, that the actor's moving, but that's a snowy background, so I think we'll probably get away with that. I have to use a different set of tools if you have motion going on, if that's on a person's face or something, but here we're okay. So I'm going to move the infected frame up. I'm going to make a copy of the clean frame, and again I'll go into mask shape and mask feather. I've already color corrected this scene, so all these clips are color corrected, so I don't have to change anything there. So you can see what I'm doing now. So I'm going to move that X. Hang on. I don't remember where it is. Put the X over where the dirt fix is. I'm going to adjust the size. I don't want to make it too big. And the softness. And then when I click on invert, frame's gone. Or the chunk of dirt is gone. Okay, so here's the next shot playing. I just find it so distracting when you see those dirt spots on the film. You know, you can get rid of them. You know, it takes the audience out of the reality of watching a film, that they're watching all these little technical impairments, which are really easy enough to clean up if you have time. So here I have a shot and 2 frames long, so I'm going to do the same thing here. So I've marked the in and out of that. I'm going to go back and see the frame before that, 2 frames before that, has a mark on it. So I've got to go back 2 more frames in order to find the same background. So I'll take our master shot, which is right there, and I'll copy that up. The clip we want to put underneath it is right here, so I'll make a copy of that, slide that in over here. There it is there. Then on this clip I'm going to put the mask shape, mask feather. Bring this down here, and I'm going to park this on top of the dirt speck. Set the size, make a soft edge, and when I hit invert, off she goes. And then when you play that out, you're not going to notice any problem. I mean, there's some other things there. There's a scratch on that film or some sort of pressure mark, so I would have to leave that up to you as compositors to deal with that, because that is just a little too thick to do as a quickie dirt fix. You can see there's other things going on there, but I think I would have to send that along to the effects department to be able to fix that, and that's a frame by frame thing, and oh boy, that's you know, you yourselves know that's a fair amount of work. But at the end of the day, you'd want to clear all that stuff off the frame and just make it as pristine as possible, so it doesn't distract from the film itself. Maybe you're saying to yourself, the projects that I work on aren't film based, but if I were to say to you, what if you had a dead pixel on a camera or a dropout on a videotape? Same principle applies. Here's our shot, and we can mark the in and the out. The shot before is clean. I'm going to move this clip up to the top. I'm going to copy the clean clip before it and slide that in underneath. Do the mask shape and feather. Mask shape and mask feather. Let's pull this down here. Make the mask nice and small. Soften it, and in this case I might even want to make it a little bit smaller because we've got quite a bit of movement there, so I'll just bring that down to 6 and 6. Hit invert. There you go. It's gone. So this, whether it's film problems, neg dirt, white neg dirt, camera dirt, or dead pixels or dropouts on videotape. This is a good way to handle it and take some ownership of your shot. Make sure it looks absolutely as good as possible before it leaves you. Okay, for this week's resources, for film basics and much more on film basics, Kodak has a lot of information, and thanks to Beverly Pasterchuk at Kodak for her help with this class. The HD Compare site is a good place to see all the high-end digital motion picture cameras compared side by side. The color corrections you're doing relate closely to the filters on the Tiffin site. You're doing the electronic version of these filters, so have a look on this website and maybe you'll get some ideas. Okay, picks this week: Hollow Man 1 and 2, both excellent films. Both contain green screen, blue screen, black keying, white keying. Just a great visual effects film, both of them, so check those out. For next week's class, we're going to talk about ergonomics, room setup, the forum questions, and we'll do a final wrap-up. Okay, that's it for Class 11. The time sure does fly by. Join me again next week, and we're into Class 12. Take care. Have a great week.